Rainfall like this can be a blessing to the farmer, but the accompanying stormwater runoff can carry waste and debris created by our industrial society. Without proper controls over industrial stormwater discharges, our streams, rivers, estuaries, bays, and oceans will continue to be damaged by pollution. It will deprive us of our heritage of clean and beautiful water resources for our water supply and for recreation. The Federal Water Pollution Control Act, better known as the Clean Water Act, as amended in 1987, prohibits the discharge of any pollutant to waters of the United States from a point source unless the discharge is authorized by a National Pollutant Discharge Elimination System, or NPDES, permit. Obtaining a permit to discharge stormwater runoff is a legal requirement for certain industrial facilities. Whether seeking a permit through a group application or an individual application, permit recipients will be subject to compliance monitoring during the term of their NPDES permit, including those covered by a general permit. Regardless of the permit type, reporting quantitative stormwater sample data to the EPA is mandatory. Therefore, you must conduct stormwater sampling. Today's training will focus on stormwater sampling equipment, the process of obtaining and processing proper stormwater runoff samples, and preparing samples for shipment to a designated laboratory. A sampling analysis plan, also referred to as a SAP, will be referenced throughout this presentation. The SAP is your primary reference for this process. The primary objective of the sampling program is to obtain representative samples of a selected stormwater discharge in a safe and efficient manner. The sampling kit and miscellaneous equipment to be used consists of the gear necessary to physically collect stormwater samples, the chain of custody form, and the stormwater SAP. Although sampling kits may slightly vary, yours may include a portable flow meter, a sampling bucket to physically collect the sample of stormwater from the discharge point or location and for preparing the composite sample, sample containers to be filled with the stormwater at specific time intervals, a sampling scoop to facilitate sampling from the collection site to the sample containers or sampling bucket, a graduated cylinder to measure portions of each sample during preparation of a composite sample, a rain gauge to collect rainfall data prior to and during the sampling event, a pH meter to test the acidity of the stormwater samples. You will also need proper personal protective equipment, or PPE. PPE includes safety glasses, aprons, and nitrile gloves. These powder-free gloves are recommended for personal protection because of the unknown composition of the stormwater discharge and to prevent sample contamination. In addition, you should have a first aid kit available that has been tailored to your particular part of the country and outfall environments. Miscellaneous equipment includes supplies necessary to perform sample collection. These include a measuring device such as a tape measure or yardstick, clear wide tape, indelible ink markers, clear plastic resealable bags and packing materials such as bubble wrap, extra sample container labels, shipping instructions and labels, the sampling analysis plan, or SAP, the chain of custody form. In addition, you will need a weatherproof logbook and calculator. The sample containers are bottles in which the samples are deposited for shipment to the laboratory. These may come from the laboratory that has been contracted to perform the analysis on your samples or purchased from your lab equipment supplier. You will need a high-impact plastic cooler, which may also serve as the shipping container to off-site laboratories. Certain sample containers may include a small amount of preservative liquid. Be careful to retain the full amount of the preservative in the container. Also, these preservatives are usually concentrated acids or other chemicals. Handle them carefully. Clearly label the container with the preservative type if you use any. If your SAP requires sending trip blanks to the laboratory in your cooler, do not open them. The laboratory uses them to determine sample contamination. Simply pack them with the collected samples for shipment to the laboratory. Estimating flow is required for sampling. The purpose is to develop estimates of the total amount of pollutants in the entire discharge. The regulations require that the storm event sample be typical for the particular area. Typical is defined as being within a 50% variance of the average depth and duration of rainfall for the area in which the facility is located. An example of rainfall data is illustrated as follows. If the average depth is 0.64 inches, calculate the variance by taking half of the 0.64 inches, or 0.32 inches, for the low limit, and adding the 0.32 inches to the 0.64 for the 0.96 inch upper limit. Use the same process to calculate the average event duration range. If the duration is 10 hours, dividing 10 in half and adding 5 to 10 yields an average event duration range of 5 to 15 hours. Keep in mind, variances to this regulation may be granted in low rainfall locations. Prior to the sampling event, the sampling team will select a sampling location. The sampling point must be representative of the entire discharge. Some facilities already have their sampling locations identified. Be sure to evaluate sampling locations against the SAP as guidance. This may mean sampling more than one outfall or discharge per facility. You must also become familiar with routes to and from the sampling location. Once you have selected a location, conduct a dry weather evaluation. There should be no dry weather discharge. Discharges during dry weather events could signify broken water or sewer lines or an illicit wastewater discharge. If dry weather discharge is present, refer to the SAP for further information and corrective actions. As a pre-sampling activity, check rainfall data daily. This activity is necessary because the EPA requires that a period of at least 72 hours transpire without precipitation of 0.1 inch or greater prior to the sampled event. There are different methods to check rainfall. You can use a traditional rain gauge or use technology to check rainfall data through websites such as NOAA.gov, which is sponsored by the National Oceanic and Atmospheric Administration. For flow proportional sampling, the stream flow will also have to be checked at 20-minute intervals throughout the sample collection process. In addition, carefully record the rainfall data prior to and during sampling. Good record keeping is very important. Include a waterproof logbook in the sampling kit to record rainfall data, including daily rainfall totals and time and date that rainfall of 0.1 inches or more ends. Before proceeding with the details of water sampling collection, realize that there are hazards involved in this process. You must always make safety your number one priority. There are both general and special hazards to be considered during water sampling operations. The general hazards relate to exposure to the elements, such as rain, lightning, sleet, snow, and wind. You may also be exposed to animals and falls from slipping on ice or wet ground. The potential also exists for exposure to chemicals in the stormwater. During heavy storms, there are dangers from flash floods and from deep and fast-moving water. There are also special hazards associated with confined spaces, which could be a danger to storm sampling personnel. People taking these samples must be properly trained and must be aware of the potential hazards. It is highly recommended that sampling teams of at least 2 people perform these tasks. Doing so will reduce the risk of injury to personnel and make performing tasks easier. Assuming an accurate event forecast has been made, the collection procedure can begin. Ensure that you have made provisions to be physically comfortable and protected from the weather. Wear properly designed rain gear with adequate warmth. Rainfall data to record during sampling includes time and date the sample rainfall event began, stream flow rate recorded every 20 minutes for the duration of the storm, up to 3 hours, the time at which each flow reading is taken, total depth of rainfall for the sampled event, and the time and date that the sampled rainfall event ended. Some installations may have access to automated sample collection equipment. This may be beneficial if allowed to be used to collect timed and/or measured samples under certain conditions. If your installation has existing auto-samplers, information on maintenance and operation should be included in your installation SAP. If you would like to install auto-samplers, first discuss with your regulators to ensure they are acceptable under the permit. Let's move on to the procedures for proper stormwater sample collection. Prior to collection, review the SAP, which deals with the sampling procedures. Check the sample container kits to ensure that all necessary equipment has been provided, is clean, and is intact. That is, there are no cracks, broken glass, etc. Label each sample container. This is very important. A labeling mistake or a missing or unreadable label can wipe out all of the effort put into sample collection. To save time, partially complete labels before beginning the sampling activity. Keep labels clean and dry. Sample label information includes the facility name and the sample number. Apply a piece of clear, wide tape to protect the label against dirt and liquids after it is completed and placed on the sample container. If a label is mismarked, relabel the sample. Do not write over a mistake. Record site information and notes in the log. At a minimum, notes should include rainfall data, times and dates of the start and end of sampling, unusual activities or occurrences, description of the samples such as sheen on the surface, color and odor, and the names of the team members. At each sampling point, collect the required amount of sample plus the needed rainfall data. Now that you have completed the sample labels, it's time to discuss the two types of samples, grab and composite, that are collected and shipped during sampling activities. Let's start with grab samples. Collect one grab sample within 30 minutes after discharge begins. This sample will be used to provide data on the first flush of the stormwater from the facility. Collect a sample of stormwater either directly into the sampling bucket or via scoop. Avoid collecting excessive amounts of solid materials immersed in the sample or floating on the surface. Transfer the collected samples from the bucket to the appropriate pre-labeled sample containers, keeping the sample well mixed during transfer. Collecting for oil and grease requires a dedicated grab sample. Collect the oil and grease sample directly into the actual sample container to be sent to the laboratory. Doing so will ensure the integrity and representativeness of the sample. Composite samples are collected so as to be representative of a flow stream over time. They are actually grab samples that are mixed together in a specific ratio at the end of the sampling effort to form a single sample used at the laboratory. Composite samples are used to provide data on the average composition of the stormwater discharge. There are two primary methods for compositing samples, flow-weighted and time-weighted. These methods differ only by the amount of each portion added to the composite sample. This portion added is called an aliquot. We won't get into detail here about time-weighted compositing, since most of you will be required to perform flow-weighted compositing. Obtaining each collected sample consists of 5 separate steps. First, obtain and record stream flow rates. Next, obtain the stormwater sample. Begin collecting samples 20 minutes after discharge begins. Once you have the sample, collect any required field measurements. At a minimum, you should collect pH. Collect samples at 20-minute intervals for the first 3 hours of the storm or until the precipitation stops. Collect those samples in exactly the same manner as the previous ones to ensure representativeness. Properly mark each container 1 through 9 and tightly seal it. Please note that if the flow or storm event does not last 3 hours, you may have fewer than 9 containers. If this is the case, simply mark and seal the containers for the samples collected. Flow proportional samples require mixing measured volumes of water samples together. Remove these from each sample based on calculations using the stormwater flow data collected during the event. Calculations are required to determine the amount of water taken from each of the 9 sample containers to make up the proportional sample. If the duration of the flow or rain event resulted in fewer than 9 samples, simply use the number collected. Take data for the calculations from the stormwater field data logbook information collected and logged during the sampling event. Recorded information includes time of the initial grab, time each sample was collected, stormwater flow each time sample was collected, and total rainfall during sampling. To calculate the ratio for each aliquot needed to make the composite sample, perform the following steps. First, determine the total of the stormwater flow rates recorded when each sample was taken. This total is expressed in gallons per minute, or GPM. In the example here, you see that the gallons per minute equals 64. Then, divide the composite sample size you wish to mix, in milliliters, by the totaled stormwater flow rates. This equals the flow rate multiplier. For this example, 2,000 milliliters is the desired composite sample size. This sample size was provided by the laboratory as the minimum amount needed to run the analysis on the sample. 2,000 milliliters is also the recommended composite sample size from the Navy Sampling Handbook. To continue our calculation, 2,000 divided by 64 gallons per minute equals a flow rate multiplier of 31.25. Multiply the flow rate multiplier by the flow rate recorded during collection of sample number 1. In the example, the flow rate multiplier of 31.25 is multiplied by the sample 1 flow rate of 5. This equals 156 milliliters. This volume is the volume of water to be taken from sample number 1 to be added to the composite sample mix. Repeat this calculation for each sample collected. To check your calculations, total the individual aliquots. This total should add up to the desired total amount of composite sample originally determined. Using the example, the totals in the composite proportion column equal 2,000. You can see that this equals the original total amount of composite sample desired. To start the compositing process, use a graduated cylinder to transfer the calculated amount of water from sample number 1 to the composite sample mix container. Ensure that each sample is agitated prior to pouring it into the composite sample container. You will be required to repeat this process for each sample collected for the composite mix. Next, pour the measured volume in the graduated cylinder into the compositing collection bucket. Repeat this step for all portions to be included in the composite samples. Then use this sample to fill each of the sample containers to be sent to the lab. Do not remove solid matter. Proper handling of the samples is very important. Seal all sample containers by wrapping a piece of clear wide tape around the top to prevent the lid from popping off or unscrewing. When they are properly protected, carefully pack the sample containers into the cooler. To preserve the water samples and ensure the physical and chemical integrity during transport and storage, cool all samples to a temperature of 6 degrees centigrade or less using ice. Pack the ice into the resealable bags and place it into the cooler. To avoid leakage, take care in packing the ice. Fill any spaces with extra bubble wrap. Close the cooler and secure it with tape. If you are sending more than one cooler to the same laboratory, number each cooler. Apply the shipping label and ship the cooler to the designated laboratory via overnight delivery service. There may be a procedural checkoff list in the SAP. Be sure you are familiar with it and use it for each sampling effort. Before concluding this training, let's review the stormwater sampling procedures covered today. Determine sampling outfalls. Then, become familiar with the routes to and from the sampling locations. Obtain and check all sampling equipment. Obtain streamflow data for the sampling location. Refer to the SAP for guidance. Monitor weather reports and predictions. Rainfall for the sampling must be considered typical for the sampling area. Prepare sample containers and labels prior to the sampling event. Make preliminary arrangements for delivery service to have the samples shipped. Review sampling procedures prior to the sampling event. At the sampling point, collect samples, including a grab sample, during the first 30 minutes. Collect samples every 20 minutes for the duration of the storm, up to 3 hours. Special purpose samples may be taken as required in your SAP. Perform calculations and sample compositing inside or in a protected area. Transfer composited sample into appropriate sample containers. Seal sample containers. Pack the samples in the cooler with ice and packing materials. Provide sample information documentation and ensure documentation is protected from exposure to contents. Close and properly seal the cooler. Ship the cooler with samples to the designated laboratory. A legal chain of custody may be required to accompany the sealed cooler. Refer to your SAP. You should now be familiar with the process of stormwater sampling, including collection, handling, custody, and shipment procedures.